green square, and flow. Hello and welcome back, I guess, to Calculus. Again, today, review for the first time today, actually. I just messed it up. Hello and welcome back to Calculus 2. This is review for exam 3. Thank you. It's been a long day. Thank you, thank you. It's 700 people ovation. Chapters 8 and 9. Sequences, series, power series. We have AN, which is a sequence, which is ordered list of numbers, ordered through set of natural numbers n counting numbers. So 1, 2, 3, 4, you can start at 0. So 0, 1, 2, 3, 4, 5, and so on. And that will have some kind of a formula, like, I don't know, 2n squared minus 5. And you can come up with terms A0, A1, A2, A3, A4, and so on. And then you have summation of AN that maybe starts at 0 and goes to infinity. It's known as series, which is sum of a sequence. And that one can converge or diverge, and you have 10 tests on the sheet that I gave you in class, and you recognize which one of the tests is appropriate to be used for a problem, and then you use it to figure out whether the problem converges or diverges. Convergent means that the sum adds to a finite value. Divergent means it adds to infinity. And then at the end you have power series, which is again, let's say 0 to infinity. Cn, maybe x minus a to the n. Power series. There are no tests for this. You can use ratio test, sometimes root test, for figuring out radius of convergence of power series. Power series are there to approximate our functions, to change functions into polynomials for ease of calculation or doing calculus. But in general, you have the, if you can't do it otherwise. So you have to be careful where you're going to do this. Yes? This one? Yeah. That is a Cn.
It's like an air freshener.
Wait, what happened? Whose air freshener is this?
Perfume again. It smells like it's like
oh. Yeah, no, it just hit me. I wasn't sure what's going on over there.
Like at first I thought someone farted.
So Nina, what happened again? Why are they covering their noses?
If you don't want to know what it goes, you hit the side of the room till like 2 seconds ago. Wait, is it worse? Is it stronger over there? Because you're like.
Yeah. All right.
She's like. Oh wow. Yeah.
Okay. All right. I guess this review is already. And there's only one test for sequences. I forgot to mention that. All right, guys. So one more time, quick review. You have sequences, you have series, you have power series. There's only one test, the limit test for convergence or divergence of sequences. Then there are 10 different tests for series. I gave you the paper. And then for power series, we have the test. Usually use ratio test, but you can also use the root test sometimes for convergence, interval of convergence of power series. So, yeah. Oh, okay. So let's see. if you have any questions. Can you speak? Okay. Summation.
From n equals 0 to infinity.
Okay.
5 to the n minus 1.
5 to the, oops, sorry. 5 to the n.
No, it's just 5 to the n and then minus 1. Over 6 to the n.
Excellent. This is, question like this is one of the favorite questions that you would see at NGIT exams. They love these questions. So if you were taking the exam there, this would probably be on the test. What I see here are two separate power series. Because I have a minus sign in the numerator, I can split this into 5 6 to the n minus summation of 1 over 6 to the n. And since both of these are less than 1, they're both convergent. Which means it makes sense for me to compute sums and the overall convergence. Why?
That's geometric.
Geometric, yes. Both are geometric. Very good. So what I have for the first series here is that a is equal to 1. So the formula is a over 1 minus r. And then on the other one, a is still 1. And 1 minus 1 over 6. So this is 1 over 6. So this is 6 minus 6 over 5. Which is, that's 5, 30, 24 over 5. For the sum, I hope. Yeah, good enough, right? Yes.
So this is just a general rule for geometry. The number on top is always a constant outside of the exponent, right? So if there was a 2 times 5 to the 6 of the n, then it would be 2 over 1 minus 5 over 6. 2 over 6.
Mm-hmm. So if you have, let's say you have something that really looks weird, then a is 6. Because these two can jump inside. You?
Can you do summation?
Of course.
From 1 to infinity of 5 or 6 the n?
Like this?
Yeah.
Well, to be honest with you, all I need to know is that pi is less than 6 and it's convergent, right? Because it's less than 1, right? Pi over pi is 1, and that's bad. 6 over 6 is 1, and that's bad. But pi is smaller number than 6, therefore, you know, you can have e over pi. It's still gonna be cool because e is smaller than pi. I don't really care that I can't really get them down to the last decimal, but as long as the number in the numerator is smaller than the number in the denominator, we have convergence.
When can you use the divergence test?
Divergence test. So divergence test, guys, on your sheet it's called Nth Term Test, which is the one on top. I told you to always try this one first. So when you get your exam in 2 days, and let's say it has 6 series to test, you should run this test first on all those 6, and then go and say, oh, this one is integral, oh, this one is, or I asked you to use root test, right? In that case, you can skip that one, right? But this is the go-to test because it can potentially knock down the problem quickly if you notice that the limit of an is not 0. So say you have summation of 1 over n. Can't use it. because it's 0. Let's say you have summation of n over n factorial. Can't use it, right? Because, again, it's 0. But if you have summation of n factorial over 2 to the n, aha, divergent immediately, because limit n factorial over 2 to the n is not 0. It's infinity, as n goes to infinity. So it is the go-to test, the first thing you try, just like for integration. What is the go-to method of integration that you always try first? U sub. If that doesn't work, then you go and you break your head or partial fraction decomposition or any other test. So divergence test is to be tried first. You are looking for limit to go to anything other than 0. Positive number, negative number, you can have 1, you can have infinity, you can have 17, doesn't matter what you have. If it's different than 0, boom, divergence. If it's 0, what does that mean? Use something else. Very good. Look at your sheet right now that I gave you. The convergence box is empty. You cannot show convergence using divergence test. Remember, no one is fat because it's skinny. Yes?
Can you also go over alternating series?
Hey, hold on,
Yes.
I have a question. Can you scroll up a little bit? More. Yes, that one. So, how did you, which test did you do for that?
Geometric.
But for geometric, you have to have 0 to infinity, right? That's 1 to infinity.
That doesn't matter for convergence. 0 matters for sum. The formula a over 1 minus r does not work here because it's not at 0. But convergence doesn't change. I can have this start at 10,000 if I want to. Convergence only depends on your r being between -1 and 1. So convergence over here is that r must be between -1 and 1. Pi is less than 6. That's why I wrote it, which means that the ratio of them is smaller than 1. So in this case, it's about half. And I know it's convergent. Now, if you want me to compute the sum, then I have to go and change the counter.
Oh, that's for the sum.
Yeah, change the counter, bring it back to 0, peel off 1, so you would have a or pi over 6.
Okay. And then when they say, like, when you have, let's say you didn't have pi over 6, but you had, like, let's say 5 over 2, that's less than 1, so that converges.
Pi over 2, pi over,
No,
5
not
over
5
2.
over 2.
5 over 2 is 2.5. How's that less than
Oh, okay,
1?
never mind. 5 over
2/5, you mean?
15 or something.
Okay, that's 1/3.
And
Good.
then they ask what that converges to. Like,
Yes,
What
in
is
that
it?
case you would have to, yes, in that case you are computing the sum.
so that's what they're asking, the sum, then they ask what that.
Converges to, yes, yes. Only 2 tests. What's the other test that gives you the sum?
Telescoping.
Telescoping, good. Now integral will give you integral equals to 2. Would that be the sum of the series? Hell no. Good. Good. So only geometric series and telescoping series will tell you what the sum is. The other tests do not tell you what it converges to. It just tells you whether it converges or diverges. Awesome.
But on the test,
What test? You have 10 of them.
no, I meant, like the exam coming up.
Oh, the divergence exam, okay.
Yes. Do you just want us to say converges because less than, 1, or do you want us to write what it converges to?
Well, you read the question, right?
Oh.
If the question says find the sum or what it converges to, then you have to find the sum. But if it says just test for convergence, no one asks you to compute the sum. Then you can just be, awesome and say, but look what I can do. Hey, it's 3,
So for alternating series, if it just asks if it converges or diverges, we don't do the absolutely or conditionally?
Yes. And we have to also address a little bit about divergence of those series. One of the conditions doesn't guarantee divergence, so we have to be careful about that as well. The divergence branch, So the limit not being 0 is the one that would give you divergence, but the decreasing part doesn't necessarily have to give that. So Daniel showed me the counterexample to that little. So we have divergence is trickier for. So we are looking for convergence on alternating series. You're looking for convergence to be either absolute or conditional. The divergence part. See, for the divergence, you know what the two conditions are for alternating series, right? You have this. Alternating series look like this. You have this -1 piece in front. And then I said that an needs to be decreasing, and the limit of an as n goes to infinity needs to be 0. And if those two conditions are met, then you are going down the convergence branch, and then you are testing summation of an. So that's different than this because it doesn't have the alternating term in it. You will use any of the 9 tests that are remaining, right? Because alternating test is no longer on that list. So any of the 9 tests here, and then that can either converge or diverge. If it converges, you get the absolute convergence. If it diverges, you get conditional convergence. The branch for divergence here, it doesn't matter for the decreasing part because, as I said, Daniel showed me the counterexample where the decreasing part was fine. It's this one which actually by the divergence test would tell you that it diverges. So you are just looking for convergence for alternating series, but you still have to know which one it is. Is it absolute convergence or conditional convergence?
That's only for alternating.
Yep. Alternating is the only one that has three kinds, let's say.
And for that like really long answer, that's the integral test that you have to.
What do you mean long answer?
Like you have to like
prove the 3 conditions?
Yeah,
Yes. Prove the 3 conditions in order for the test to apply. If those conditions don't hold, the conclusions of the theorem don't hold. Might not hold.
But our answer is gonna be the
the paragraphs, explanations, yes. I'll leave 2 pages, don't worry about it.
That's for integral test.
Yes.
Only for integral test?
No, we also have the direct comparison for the comparison test where you have to show that you can also write beautiful paragraph for comparison tests. With both limit comparison test, also you can write why you are picking certain value to be your Bn, like certain sequence to be Bn. So that's also nice opportunity for you to show off your writing skills. Yes.
Do we memorize like what you wrote for the answers, or do we just like
No, just say it. Then no. Don't memorize what I said. It's just, everything in mathematics is you have the set of conditions and then conclusion, right? So as long as you are worded in such way that it's clear that, because these conditions are satisfied, this is the conclusion, you're good to go. You don't have to use my wording. It just needs to be clear wording where you say, because the 3 conditions for integral test hold, we are able to do the improper integral. Because the conditions hold, the integral converge, the series converges by the integral test, which is a theorem, right? So
speaking of the integral test, it looks like pretty much all of the tests have like a format that you know which test to use. But with the integral test, I don't know when you use that. Do you use that if none of the others work?
Well, the last resort tests are actually comparison tests, which is why Larson sticks those 2 tests all the way on the bottom. You always want to try divergence test, which is first. You will clearly recognize subtraction for telescoping, clearly recognize the form for geometric series, see the mixture of different types, polynomial with factorial with this for ratio. Root will have everything raised to the same power. And so they're all, as you said, but then you run into 1 over n ln n. Oh, that's perfect for substitution, right? So you really, integral test, you actually see that you can integrate, right? You can't integrate if you have factorial floating around. You definitely don't want to integrate if you have any of geometric series looking things, right? Because integrating those kind of, 2 to the n, and right, they get to be complicated. So integral test is used to something that you can integrate, right? And you are looking into those technically, with ln's. But then what I can suggest you to do to kind of learn the form of the integral test is just open up the integral test homework in a textbook, not online, but in a textbook. If you don't have this textbook, you have some textbook for calculus, or go to the library. Open the homework for integral test and stare at the problems to see if you can integrate each one of them like this. Because if you are not recognizing integral test, it's because you don't see it that you could integrate it, right? For me, I look at the series, and if it didn't fit technically anything, integral test is technically, for me, second to last, right? Because the comparison tests are on the bottom. So I'm just going to go through my head and make sure that the limit is 0, right? Because the divergence test didn't kick in. And then check it against all other tests, and then integral test. And if that doesn't pass, then it's comparison. So it's like a second to last to check for the integral. Unless the problem says use the integral test. In that case, right?
And then for the exam, are we allowed to do the divergence test in our head, or do we need to write it out? Because you said do the divergence test first every time.
Yeah, but you can just do that by looking at the problem.
Yeah,
you don't
exactly.
actually have
So
to.
we
Yeah.
can do that.
No, you don't have to write it out for every problem. You just see, you see summation 1 over n. You know that goes to 0. There's no need, right, to write anything down. But you might want to do the quick check, right? Some of you might have to actually take the limit a little bit, but remember, every other page on the test is empty. You don't write on a desk. I mean, you're not going to submit a desk, but still. You erase it afterwards. Yes?
So there's a question in the Larson book that they use integral test for, but couldn't you easily use divergence for this example?
No, probably yes, but no. Divergence test for that one would give you 0, right? Because it's smaller over larger. I'm just going to write this problem real quick because, guys, this problem is awesome because it can be done in 2 ways. And thank you for giving this one. This one is really cool. You gotta consider this problem for the future exams, man.
You put it on the final.
Final is one of the future exams. So all right, so looking at this example, I hope that you guys clearly see immediately that you have U sub there, right? U sub solves this like nothing. You don't even have to write it. It's clearly 1/2 ln of x squared plus 1, right? Like that.
Yeah.
But then, right? You see that because you know how to do U sub. It's not a problem.
Say that again.
It's 1/2 ln of n squared plus 1, x squared plus 1, right? And then when you plug in infinity inside that x in the ln, the whole thing blows up and it's infinite, which means that the integral would diverge, which makes everything diverge. So you know that by integral test, this divergence will do those conditions first, right? You know it diverges by integral test. But can't you also say, you know what, let me look at this problem from far away where I can't see that plus 1 using the comparison. Doesn't this cancel down to 1 over n? And we know that summation of 1 over n is what? Divergent. That's harmonic series, right? So you can do this problem by integral test, which will take you a page and a half because of the proofs, or you can do it by a comparison test, which will solve it like that, right? Now, clearly, if the problem says use the integral test, right, then you have the comparison test to kind of verify that you were right. Because, some problems you will be able to do it 2 or 3 different ways. Some problems you're stuck with the only way you can, which is, the root test or
feel like that was spoken or something. You look on some, what's that?
Which comparison?
It doesn't matter. Could you walk us
Wait.
through it?
You can do it.
Sure.
Now, which one would you like, comparison or the integral?
Comparison, they're all okay. It's a little fuzzy.
Yeah, he wants paragraphs. He wants to see some writing.
Hang on. I can do the paragraphs. I'm just a little fuzzy on the comparison.
On the comparison.
Like the action, yeah.
I got nowhere to be.
Yeah, just do the
Integral test.
Oh, boy.
I know. Are the terms positive? Yes, they are, because all n's are positive, and we don't have any subtractions anywhere, so all n's are positive. Positive, you will write this out. Divided by a positive is the positive, so all positive and done deal. Yes, good, nice. Is it decreasing? Well, we are going to look at x over x squared plus 1, and we're going to take the derivative of that. If the derivative is negative, then it is definitely decreasing. So let's take the derivative. The derivative is going to be quotient rule. So we have x squared plus 1 in denominator squared. I don't have to look at that because that's squared. That's always going to be positive. So I just need to worry about what's happening on top, which is x squared plus 1 times the derivative of x is 1. So I can just leave x squared plus 1 minus the derivative of the bottom, and the derivative of the bottom is 2x times the top, which is x. So you have negative x squared plus 1 over the positive value. When you start at 1, the first number is 0, and then from that point on, all are negative. You always have negative divided by positive. So that's less than 0, meaning it's decreasing. Great. Boom. So, and then the last one, so positive, decreasing, and continuous. Yes. So can we make denominator somehow equal to 0? Nope, right? Denominator cannot be equal to 0 because you get complex values are the ones that make it 0. So great, it's continuous on 1 to infinity. Boom. Those are the three conditions. You will write paragraphs around this, obviously. And then we go immediately into integral test from 1 to infinity of x over x squared plus 1 dx, which is the limit. B goes to infinity of 1 to b of x over x squared plus 1 dx, which is the limit. B goes to infinity. You use u sub, so we clearly get 1/2 ln of x squared plus 1, which blows up. So since three conditions hold and integral 1 to infinity x over x squared plus 1 dx diverge, series summation n over n squared plus 1 diverge by integral test. Boom, done. That's how you do integral test. Now this is abbreviated. Obviously you will write the stuff out. Now same problem, but we are looking at now with the comparison test because we can. So this is a problem, and I know that my an is n over n squared plus 1. I am going to take a look at the bn as 1 over n because if we ignore plus 1, it cancels to 1 over n. Now I know that summation of 1 over n diverges by, you can either say p series or you can also say or integral test, whatever. So now we can do limit comparison real quick, where you take your original problem, which is n over n squared plus 1, and divide, oh, I forgot the limit. Limit n goes to infinity. Boom. Original problem, n over n squared plus 1 divided by 1 over n. If the limit is finite, both series do the same thing. So what do I get here? I get limit of n squared divided by n squared plus 1. And that limit is 1. So, since limit is finite and summation 1 over n diverges, series summation n over n squared plus 1 diverges by limit comparison test. Done. So that would be the answer, the sentence. This is what carries most of the points right here, because you are displaying the knowledge, of the theorem, and then the things up there are calculations. So again, you ignored that plus 1, which has it now to be n over n squared, which cancels down to 1 over n. We know that the summation of 1 over n diverges by harmonic series or by p series or by integral test. Pick your poison. So that one diverges. Then you are doing the limit comparison. AK over BK, AN over BN. And then that gave us the finite limit. Because the limit is finite and summation for BN diverged, then the summation for AN, which is the original problem, will do the same thing, which diverges. And there you go. That's it. Done deal. Down.
Since there's 10 series tests,
yes.
the test mostly going to be that.
Well, on the exam, you must expect at least 2 power series problems, maybe 3. I'm not going to ask every single test. You must expect ratio test at least once, maybe twice, but at least once. Because ratio test is also giving us the radius of convergence and interval of convergence of power series. So you might have a series question and that one. So you could see 2 ratio tests. You should see integral test because it's so awesome, right? It ties a lot of stuff together. We are talking series, we are talking those proofs, we are talking derivative for decreasing, we are talking improper integrals, right? So it's like one good quality question, right? Like 70 points in the test. And then you definitely should see at least 1 geometric series because that's a freebie, right? We all love that. Except I decide to make it the worst nightmare, which is shift the counter and then it's just, yeah. Then you should also know how to convert from the numbers into the formula, because that could be something cool. Yeah, you have a sequence of numbers and you convert that into a formula. That's cool, right?
Yeah.
And then for power series, I mean either the derivative or the integral, you know, something that it's cool. You gotta know how to do the Taylor expansion. So to get, you know, get the first 3 or 4 terms for something. So write the first 3 terms for e to the sine x, right? Then you go, oh, those are the nested series, right? Put one to the other and then it just expands. So the gods of all tests are clearly root test, ratio test, and then integral test, and then geometric, right? So those are the ones. You already know that you are supposed to try divergence test, the Nth term test, on every problem before you even start anything. You should review your L'Hopital rule because you're taking limit in every problem. So if you mess up on the limit, that's like a face palm, Calc 1 face palm, because you are in Calc 2 now, right? So getting points off for a Calc 1 thing is just, and then even worse if you're not able to peel off something, for algebra, not knowing that, 2 to the n plus 1 is actually 2 times 2 to the n. That's algebra, and if you're losing grade in Calc 2 over it, then that's that part. So should be one sequence question, which is just figure out the test, right? You only have one, you just take the limit. It either converges or diverges. One alternating. Hopefully you are not forgetting the rule, right? What we talked about, that for alternating series, that minus 1 to the n can also be written as cosine n pi, right? So what do you do if you see other sines and cosines other than cosine n pi or sine of n pi over 2? What do you do for other ones? Yes. What do we do with random sine n and 3n and whatever? So what do we do with them? You didn't? Oh, you forgot that? Ooh, that sounds good. Maybe you should look into that.
Can you repeat the question?
What do you do with sine n or sine 3n or sine n squared or sine 1 over n or sine 1 over n squared plus 3? You just ignore it. Like it's not there. Because it goes from minus 1 to 1. That really can't mess up your overall divergence or convergence. Yeah.
So you're saying if it's sine or cosine and then some variation of sine and cosine are alternating no matter what?
They do alternate, but they don't give the impact because they're bounded.
Okay.
Sines and cosines are bounded between minus 1 and 1, right? So they don't really contribute to the sum.
So you're saying just ignore them.
Yep, for the in general. Unless they're these. They give you alternate series then. What's up? You said you have a question.
No, I was gonna fair one.
Oh, too bad. I'm just trying to the tree branch thing. So I get that bit. If it's not, if the limit isn't 0, or if it's divergent, then it's divergent.
Don't worry about decreasing.
Don't worry.
Don't worry about decreasing.
So you're saying
Increasing will not make it divergent.
So if limit is 0 but it's increasing, then what?
So if it's increasing, then you just treat it as if it's still going on. So we don't even need that.
Lunch and old lectures. That is the way we do it.
Can you give us just like a question in your head that would cosine? There's none in the book.
Oh yeah. I was when I was scrolling through the videos. We did videos for
That's the
That's the
and
finding
it's like, okay, scroll through them, pick the good ones. And I was trying
Hey, you lived! Congratulations, Calc 2 is over.
And I was like, George, it's not working. I pressed really hard.
All right, I'll see you all.